One. And we have liftoff.
Tutto è nato perché io da diversi anni.
It all started because for several years I've been trying to find a way to study cerebral venous return in a non-invasive, simple, reproducible and reliable way.
È attendibile. Il principio fondamentale è che la vena.
The basic principle is that the internal jugular vein pulses and transmits pressure from the heart to the brain direction. We are able to measure these pulsations with accuracy and very easily by ultrasonography.
Molto facilmente con l'ecografia.
The further step aimed to collect the same signal by means of a simple gauge strip, which could be worn around the person's neck.
Al collo dalla persona.
In 2013, an Italian space agency call for proposals came out. It was extremely interesting to me because it gave me the opportunity to improve a prototype I had created, but did not have all the qualifications to fly in space.
La richiesta di ASI, infatti,
the Italian Space Agency request aimed to experiment human physiology and investigate the effects of weightlessness on cerebral venous return. So it was a perfect fit. But what was missing were the qualifications in terms of engineering of the rough instrument we had created, and also in terms of safety during space flights. So I asked for help to my colleagues at the Department of the Medical Physics Group, in particular to Professor Taibi.
Al professor Taibi.
After Professor Zamboni contacted us, we worked together on a proposal that was funded in 2013 by the Italian Space Agency, the Drain Brain project, as we were interested in draining blood from the brain to the heart. Thanks to this funding, we developed a pletismograph, which is a diagnostic device that measures changes in volume of any cylindrical object. We wanted to understand how we could measure this signal at the jugular. In the first phase, we combined pletismography and ultrasound measurements, this latter already present in the Columbus module, a module developed by the European Space Agency in order to make physiological adaptation measurements. These measurements led to a very interesting result, i.e. the evaluation of the jugular pulse. The experiment saw its final phase in 2015 when Samantha Cristoforetti, the astronaut of the European Space Agency, reached the International Space Station at the end of 2014. We sent our pletismograph to the station and she conducted a series of experiments for the 6 months she has been in orbit. The experiment included a pletismographic measurement and also an ultrasound measurement. The ultrasound system was already on the Columbus model, which is dedicated to physiological adaptation to carry out several different experiments. In 2015, at the end of the Drain Brain experiment, we realized that by using the pletismograph, we could measure these oscillations produced by the jugular venous pulse waveform. So the idea was to develop an autonomous diagnostic device, as the ultrasound always needs the presence of an operator. Therefore, it is not suitable for the telemedicine purposes and remote monitoring. That's why we created a new pletismograph that not only had the ECG trace, but also the ability, thanks to a much finer sampling, to follow these oscillations and create a jugular venous pulse waveform by using only the pletismograph. Beyond the success in orbit and the experimentation in microgravity conditions, the focus of our clinical-oriented interest is the experimentation for cardiovascular diseases. So, in recent years, we have also taken fundings from the National Institute for Nuclear Physics to engineer a new system that integrates pletismography with an electrocardiogram. We have developed this system, and then there was the extraordinary opportunity of a new invitation to tender human space flight from the Italian Space Agency. We participated and won with the project Drain Brain 2.0. The idea is to propose a new diagnostic device capable of synchronizing ECG to the pletismography.
Alla pletismografia. Siamo molto orgogliosi di questo nuovo finanziamento dell'Agenzia.
We are very proud of this new Italian Space Agency funding. At the same time, we hope to bring this device to a clinical level, i.e. manage to create a device that can monitor patients affected by cardiovascular diseases and above all, for telemedicine purposes.
Soprattutto per scopi di telemedicina.
Quello che abbiamo ottenuto è un magnifico esempio di interscambio.
What we have experienced is a wonderful example of scientific interaction. We now have an instrument that is not only able to fly and reproduce accurately the signals of the cerebral and cardiovascular circulation in the space, but we also have an instrument that, based on the data we already have, can also be used in a clinical setting for the good of the patients.
In un setting clinico a favore dei pazienti.
We really think that the interchange between space, clinical outcome, and us will be of great help for patients.
Interesse per i pazienti.